Master Anatomy and Physiology with Indramani Pandey.
Welcome back, guys. This is another lecture about human anatomy and physiology. In last lecture, we covered the structural organization of the human body, survival needs of the body, and the life functions. In today's lecture, we're going to cover homeostasis first, then we will move on to the different regions of the body, planes, directions, and some anatomical terms. I hope this lecture will be helpful to understand the basic concept of homeostasis and to understand the importance of the homeostasis in the human body. Let me start with the homeostasis. The term homeostasis is firstly coined by Walter Cannon. It's all about maintaining the normal body conditions, regardless of the environmental conditions. And it is the state of dynamic equilibrium. Organ systems perform work together to maintain the normal body condition. For example, your normal body temperature is 37 degrees Celsius or 98.6 degrees Fahrenheit. How do you achieve your normal body temperature? What will happen if your body temperature rises? And what will happen if the body temperature decreases? Ions like calcium, potassium, and sodium plays a vital role in molecular level to maintain your homeostatic balance. The homeostatic control can be achieved by two ways, which are positive feedback control and from negative feedback control. Before we move on to the positive and the negative feedback control, we need to understand how the information are processed in the body. There are thousands of receptor cells in your body which work together to get information from the stimuli. If you touch the hot pot, you feel hot. From the receptor in your skin, the information is received. Then the information will be traveled to the control center through afferent pathway. That is called input of information. The second component, which is the control center, processes the information. In our case, the brain is the control center, which will command or give order to do tasks. The information from the control center will be received by the third component, which is effector or damage site. The effector will get that information from the control center as an output information through efferent pathway. Then the action will happen. Remember that control center determines the set point, which is a physiological value, which is a normal physiological value. You need to understand that. The normal physiological value of temperature of the human being is 37 degrees Celsius, which is a set point. Now let me talk deeply through the flowchart in back of my whiteboard. Let's see that. As I told you, the homeostatic balance takes place through different ways, through positive or negative feedback control system. But here, what I want to show you is how the information is processed or how the information travels from one part to the another and how your body reacts on the stimuli. Let's see that. Receptors get the information from stimuli. Stimuli may harm you or stimuli may suggest some information too, but stimuli are different types. Okay, so when the receptors get the information, it goes through afferent pathway to the control center, as I told you before. The information will process there, and through the efferent pathway, the command will go to the effector side and the action will happen. Okay, And I will give the example right here, okay, about how the effector receives that information and what happens. Now, as I told you, there are two types of the control system through feedback mechanism, which may be positive or may be negative, depending on the feedback, which may enhance or slow down the stimulus. Let's see the positive feedback. In human body, the positive feedback works during blood clotting and the uterine contraction during childbirth, while the negative feedback works when maintaining the body temperature, maintaining heart rate, and maintaining blood oxygen level. Okay, that's very important thing to remember here. And as you see in the chart here, I show you the heart rate here too. And it is important to understand why the heart rate should be on its set point, which is 72 beats per minute, right? So that is the very important thing, which is the set point for heart rate. So which is controlled by negative feedback. Let me tell you that negative feedback response sorts off. Okay, in the case of negative feedback, response will sorts off and the intensity of stimulus will decrease. But in the case of positive feedback, response enhances the original stimulus so that the response is accelerated. That's why it is very important. Control of blood sugar by insulin in your body is also a type of negative feedback. The endocrine system involved in the homeostasis during controlling of the blood sugar level in your body. That is very important to understand, right? Okay, let me tell you about positive feedback. The positive feedback, the example is blood clotting, as I mentioned just 1 minute before. The blood clotting is a perfect example of a positive feedback control. How it works? When you cut your finger, let's say, the blood starts bleeding. You're going to start bleeding, right? Then what will happen? Platelets will come and they will adhere to the surface and try to block the open space so that the blood will not come out. Okay, and what will happen? Platelets will form several layers. The platelets, whichever comes first, they try to attract more platelets by releasing chemicals, and finally the blood clotting happens. That's a good example we need to understand. And the positive feedback basically works during infrequent events, okay, that you do not require to adjust all the time. When you're scared, when you get fear, like those types of things. Another example of negative feedback, if you're talking, like if you want to know, is when you get hungry. What will happen is if you smell some hamburger and if you smell some chicken nuggets, what will happen? You're going to start producing saliva in your mouth. When you get that food, what will happen? The saliva level will go down little bit. When the food is finished, the saliva stop producing itself, right? So what will happen finally? The stimulus will stop. Okay, that's very important. Now here I draw an example for the negative feedback, which is the body temperature. As shown in the picture, there is a hot environment and there is a cold environment. In a body temperature, the set point is 37 degrees Celsius. And when the body temperature rises, what you gonna do, what's gonna happen? Your body gonna feel hot, and the sweat glands in your body trying to produce what? More sweat. And what will happen? Your body starts cool down and get the set point. If the environment is cold, what will happen is your body starts like feeling cold, right? And what will happen is you're gonna start shivering. What I mean by shivering is the skeletal muscles in the body trying to vibrate. You're gonna feel shivering and you're gonna generate more heat so you can reach the set point and maintain the equilibrium condition. So you're gonna get or you're gonna achieve the dynamic equilibrium or the set point to maintain the whole body system in normal. So what will happen if the homeostatic balance is disturbed? It basically happens during the old age. What will happen is different types of environmental factors will affect your body and you may get sick. For example, like bacteria in the environment, they are just like widespread, they can enter your body anytime. If they find your body is a host or is a like good environment to survive. For example, the thermophiles bacteria loves hot environment. If your body is too hot, they may find good space in your body and try and degrade that. You're gonna feel sick, you have to seek the doctor to cure the disease. So that's the importance of homeostasis. If something is just like the ionic level, in the ionic level or the molecular level, if something happened to the ion channels, what will happen? The ion may not pass or ion may not reach wherever it want to go, then your body start like feeling like sick, or you may die also. Okay, like systems are not working, that means you are not functional, right? So that's why homeostasis is very important. Through osmosis or through diffusion, whatever you're talking about, a cell to cell diffusion process, you maintaining your homeostatic balance, so you need homeostasis. Okay, so that's all about homeostasis. Now we're going to talk about different regions, different directions, planes, and some anatomical terms.
Please subscribe to see more videos regarding anatomy and physiology.